Hi, everybody. Dr. Krausen here, and I'm going to spend some time talking about our Markdown files, basically what they are and why you would use them, and also how to create them, and for the purpose of essentially knitting a document together, essentially a document that contains text, code, and output. So that's really one of the big benefits of our Markdown files is you think about it as essentially text and code, and it's essentially providing instructions for knitting together a document such as an HTML or PDF or perhaps Word that contains text, code, and output. Okay, so think about it from that kind of perspective. So it really is very useful for documenting your analyses, or where you might want to reference it in the future, or sharing, you know, uh, output and your interpretations or whatever with other people, and also incorporating the code as well. So at this point, what I'm going to do is open up RStudio, and I'm going to go through, I'm going to talk a little bit about the console. I'm going to build on that to kind of show you what the script editor offers over the console. And then finally, we're going to pick up with R Markdown, and I'm going to show you how that is beneficial over the using the script editor in R. So what I'm going to do is I'm going to go ahead and share my screen right here, and we're going to go ahead and open up RStudio. See if I can find it here. There we are. So I'll open it up and just to kind of quickly take a look at it. And you'll see in RStudio, there are various panes. On the left right here, you're going to see essentially what's called a console. And in that console, you're going to see, down below, you'll see that there's a place where we have the blinking cursor. If I click on that line right there, then I get a blinking cursor, and that's where I essentially am going to type in code. And when I hit enter, after entering that code, then it's going to produce, whatever output. Um, so you can do this line by line. Honestly, I think of it as it's useful if you're going to do like a little small thing, but it's not particularly useful when you're dealing with many lines of code. I don't know why that's showing up there. And so that's really where the script editor comes in. Also, with if you're using the console to type in commands or code, if you will, you're not able to save it. Okay. So if you use a script editor, though, you can actually save the code that you have written so that you can call it up later and use it with your data set in the future. Or if you want to rewrite the code or add to or take away, you can do that using the script editor. So I'm going to just kind of walk you through what I'm talking about with this, just so you can kind of get a better idea about what really ultimately the benefit of R Markdown is, and then we'll go into really the how-to process. Okay, so right now we are in the console, and we'll go back down to our little cursor here, and this is where we would enter various codes. So let's just say I want to examine the structure of a data set that actually comes with the base R, if you will. And that data set is referred to as cars. And when I say data set, what I'm more specifically referring to is a data frame. So essentially, a data frame contains the data that you're going to be using to analyze, or you apply various functions for the purpose of analysis. So to give you an example, I'm going to type in str. That's a function in base R. And so with all functions, by the way, you've got the name of the function and then followed by parentheses. And inside those parentheses are arguments that are essentially, referencing the data itself or the data frame, and or particular variables and so forth. And there's other options as well. But the structure function, we're just going to reference cars because that's the data frame that contains the raw data that we're going to use in this example. So I'm going to type in cars right here and hit enter, and you can see that you see that we have a data frame, and we have two variables in this. We have speed, we have dist right here. This is distance. Essentially, this is raw data. This is kind of a, I want to say, classic data set, if you will, if for no other reason than for purposes of instruction. Um, so with this, the speed is essentially, these are characteristics of cars. And so one is essentially how fast a car is going in miles per hour. So that's the speed variable. The other one, is distance, essentially stopping distance in feet or whatever. So you can see that just by typing in SCR cars, we get that you know. Some information on the structure of the data frame and characteristics of the variables within. I will mention too that when you're working with R within the console and also with the script editor, if you type in something like this is info on the structure function, you'll find that if you hit, excuse me, you'll find that when you hit enter, you get an error. And the reason why is there's no function that is given right here. And this is text that's not being recognized as a function or anything else. And so that's why it's saying, that's why you're getting the error message right there. Now we could actually, not get an error message if we were to comment that line out. So if I was to use a pound sign, which is essentially used in R for the purpose of creating comments, you can space or not space. I'm just going to space. I'll pay. Oh, excuse me. All right, so I'll get rid of that. That's for later. Um, so let's just say, this is info from on the structure function. I'm going to copy this and I'll paste it down here and then hit enter. And you can see that now we don't get an error message. It's just simply a comment. And so because there's no function that's applied, you're not going to get any output right there. But that's an important thing to keep in mind, when you are later when we're working with our script editor. So at any rate, the console, like I said, it's basically, very useful. It's useful in those cases where you want to do something quickly on the fly. Maybe you're not necessarily interested in keeping a record of what you're doing. I rarely find this useful for anything that involves, multiple lines of text where I'm interested in saving the code and for future use or just for documentation. So that's what I'm talking about with respect to the console. So again, it's useful for maybe a quick, you can enter, functions and everything line by line, just enter the code line by line and carry out things. And you'll just get sort of a line by line output, if you will, as you're going through. But again, it's not particularly helpful because it's except in a limited sense because you can't really save the code that you have written. So now what I'm going to do is I'm going to go to File and click on New File and then go to RScript. All right, so I'm going to click on that. And under RScript, this is where we can actually, we can keep a record of what we're doing, and we can also incorporate comments. So a lot of times you want to provide annotations, discuss where you're talking about what maybe the functions mean or what packages are being used and so forth. So you can comment those lines out by using the pound sign. You can, as I mentioned before, though, you can't just write text in and then have function then try to run it all because the text is what you'll end up doing is you'll get an error message because that text is not going to be recognized. The only way to to not get an error message is to comment those lines out. So let's just say that I'm going to use a pound sign right here, and I'll just say examples using cars data. Okay, and more specifically the cars data frame. Okay, so in this case, I'm going to use the library function, and I'm going to type in psych. Okay. So essentially, thinking about functions in R, basically what you have is library, that's a function. And what that function does is it calls up a package. So the name of the package that I'm referring to is psych. And so that psych package contains various functions. So think about all packages as containing a collection of functions. And so in order to access those functions, you have to call up the package. So it's not, those functions are not just automatically there for you to use, even if you have the package saved to your computer. The only thing you can do, the only way to use those functions is to call it up using the library function in most, as I'm showing you right here. So that's the first line. So the next line, I'm going to use a function. I'm going to use the function describe from that package. And so you can see describe, and then we have our parentheses. Just keeping in mind that all functions, essentially, whether it's library function right here, whether it's a describe function, they have a basic structure, which is uh, you have the parentheses, and then contained within the parentheses are whatever arguments that you are using in order to carry out uh, um, for the function to operate on, if you will. So in this particular case, I'm going to type in cars right here. And so again, we're the function down below, we use the structure function right here. Again, you can see that same general structure, which is function, parentheses, and then inside is the argument. In this case, it's the name of the data frame. All right, so if I highlight these things and run, you'll see that I get down below, you can see that you'll see first off, you'll get the code that was written, which is library. Basically, that's the function using the library function and applying it to the site package, and then the describe function as it applies to the car's data frame. And so there you go. Now we have descriptive statistics on the two variables that are contained within the data frame. You'll notice too, if I highlight all of this, even the pound sign, the commented line, if I click on run, that shows up as well. It doesn't really do anything, but like I said, a lot of times you might want to incorporate comments. The limitation, of course, is that if you have long text that you want to use for annotation or whatever purposes, you can't just write a long line of text without that pound sign. And there's not going to be a wraparound with when you're using the comment either. So I can say. There is, let's see, examples using car data frame. Uh, I am illustrating use of functions in RStudio. You can see right here, it sort of wraps around, but obviously it sort of goes off the page. And, a lot of times we don't want to do that. So let's say I want to carry it over to the next line. So I hit it, do a hard enter right there. So now you can see that on the next line, everything shows up in black. So now if I run all this without the commenting that line, you'll see that I get an error. So you can see right here, it says unexpected symbol and I am, and that's because there's no comment. If I add a pound sign right there, and if I highlight all this and run, then everything works. If I just want to run this without the comments, I can do that as well. So there you go. So as you can see with the script editor, you can actually go over file and you can save the script that you have written and then call it up for future reference when you are working with further with your data and performing analysis. And so with the script editor, you can make modifications to the script, you can add to, you can take away. It doesn't matter. It's useful in those contexts. And as I said before, you can add some commentary through the use of the pound sign, essentially commenting various lines. You just can't You just can't start a new line without a pound sign. Every line has to start with a pound sign. And so you can see how this would be really cumbersome in those cases where you have a lot of text, and you want some, in that particular case, you'd be using a lot of pound signs for every line of text that you would want to create and incorporate. So as you can see, as I said, if you use the console basically is useful for like I said, line by line analysis. I rarely find this useful, um, and most of the time, as a data analyst, I'm going to want to save my work, at least at a minimum, save the code that I've written on a given project. And so this is an example of doing that using the script editor. So at this point, though, if I just save what's in the script editor, I just have the code. So if I want to run the analysis in the future, what I would have to do is to literally go, open this up, re-highlight, click on run, and generate the output right there. And you'll notice the output is never going to be saved to the script editor. Okay, so in that particular case, that's one of the limitations of the script editor, and and really, to my way of thinking, one of the big motivators behind using RMarkdown, because with RMarkdown you can create text. So, and you don't have to use these comment lines like I'm using right here, with it, because there are certain within certain space in our Markdown file, you can just create a text that wraps around and so forth. There are certain formatting rules, like, if you want to italicize and things like that, you can also do that using those kinds of rules. Or if you wanted to incorporate inline math or Greek symbols or whatever, there are rules for that. But you can still create text that incorporates all of those things and not have to use pound signs. And obviously here you couldn't even even as a commentary you couldn't create like an inline equation or Greek symbols or any of that sort of thing. So in that particular case, that's one of the benefits of our Markdown right there. Uh, is that you can document what's going on, and within code chunks you incorporate the functions that you're using, and also you can comment within those code chunks in this kind of way using pound signs. You just uh, but you can't use sort of the same rules, or you can't simply use wraparound like you would do in those areas that are devoted to textual information. So at any rate, so you've got text, you've got code chunks, which is basically incorporating whatever functions and so forth that you're going to be using with your data analysis, and then that's going to be throughout the document. Now, what the R Markdown file will do is, depending on your setting, like if it's HTML, PDF, or Word, depending on your setting as a default, what will happen is that when you knit an from the R Markdown, it's going to knit together, like for instance, an HTML file. The HTML file will contain the textual information. It'll contain the code that you have written, and then it will also contain the output that would be generated from running the code. Okay, so you can see right there that that is really super handy. You're not just limited to just having the code itself, and you're not limited to using commenting of lines. Now you can incorporate textual information that will essentially allow you to be a lot more detailed in what you're describing, and then also, like I said, you'll incorporate the code chunks and then the output that would be generated through using when you run your data analysis. So it all knits that together all at once, and that's one of the really big benefits of our Markdown. And so you can see that how that is a big leap over just using the script editor and then calling up the script and then having to rerun your analysis in the way that I was just talking about. One thing to kind of keep in mind too is that R Markdown does have to be installed on your computer, or yeah, it has to be. The R Markdown package has to be installed. Let's put it that way. So, if you go under, file right here, go to new file, you may see by default R Markdown right here. That doesn't necessarily mean that it's been installed. And so if you click on that, I believe I've seen situations where there's, maybe something comes up that maybe says install R Markdown, and you can install it there. I believe I've seen that before. But if you wanted to do it using the install packages function, the way that you would do that is you could just open up a script editor, or you could even go down to the console and type the following. You can type in install period packages. Okay, so this is another function in R. And so inside quotation marks, we'll type R markdown, mark down, and all the letters are in lowercase. Okay, so keep in mind when you're working with R, um, the case, the letter case matters. Okay, um, there's no close enough or gee, it'll figure it out or anything like that. If you don't have the case correct on the letters and or whatever symbols that you might have as you're running things, there's or correct spelling or any of that sort of stuff, then you will get error messages. That's just it. You have to be perfect essentially. So at any rate, I'll just kind of show you what happens if I try to install this package. Like I said, it's already installed on my computer. I'm just going to kind of redo it here. But if I use a capital R right here, I'll show you the error that happens. I'll just highlight this and run it. And you can see down below that it's got a warning message, and it says package R Markdown is not available for this version of R. The reason why is because capital R Markdown is not a package. It doesn't exist. It can't be installed because there does not exist that package. So if I type little r markdown and highlight this, then click on run, then it's going to go through the process. You can see down the console, it working, it's thinking, it's going through the process of installation right there. And so you'll know that it's finished when that little stop sign leaves. And so now you can see there's no stop sign. So it's been installed. So now what we're going to do is we are going to open up uh, the R Markdown file. We're going to go in here, click on R Markdown, and with the R Markdown file, these are basic defaults. So for the title, you put that in. So I could say example of R Markdown, R Markdown, a Markdown file. Okay, you can see my name right there. That's just kind of default right there. There's the date. You can see too that the default output format. Remember, we're going to knit together text, code chunks, and output into an HTML file if I leave this default on. And really, I'll be honest, most of the time when I'm doing, heavy coding or heavy writing and so forth, I will focus on, I'll use HTML really because it renders a lot more quickly than using PDF. It doesn't mean you couldn't do that, but PDF just seems to take a little bit longer. And if time is a little bit more of essence, you can just use HTML, and that kind of helps out. It's nice because you can kind of see the formatting and everything stitched together as you're working along. So even as I kind of go through and maybe I change code or modify code or add code or remove it or change text and so forth, I can kind of see the results of that pretty quickly. If I wanted a PDF, I can render PDF files, but you have to keep in mind that it does require packages that allows for that particular formatting. So I believe there's like a package called Tiny Text. Essentially you're using LaTeX formatting. So you could certainly do that as well. If you want to use the PDF though, you do have to install those LaTeX the latex package or packages before you can actually use that. Otherwise, that little stop sign, following the stop sign, you're going to get essentially a bunch of red that's going to say, we could not render this. And so it looks kind of uninviting for sure. So I'm just kind of giving you a heads up on that. But for the focus in this demonstration, we're mainly focusing in on HTML, rendering an HTML file. So at this point, I'm going to click on OK. And when I do that, you'll see that over here on the left, now you'll see that we have an RMarkdown file. It's essentially contains a bunch of defaults, except that, now we've got my little title right there, my name again. You'll see where it says output, you got colons and it says HTML underscore document. So obviously that's instructions to render an HTML document. So if you don't have that in there, you're going to get an error message. So you do have to have HTML underscore document. That was just basically created by default because we have that button for HTML clicked. This right here is a code chunk. Basically, code chunks start with three back tick marks, and it also ends with three back tick marks. And then you'll see that following the back tick marks above, you'll see a R, and then there's some other information. Perhaps most of the time I just type in R and then the end bracket as you see here. So these curly brackets, you'll have R within curly brackets. And then as you can see right here, there's some other stuff, but we're not really going to get into. This is a default that oftentimes I just don't maintain in my R markdowns. It's kind of cluttery, and I really have not seen it have any real problems if I remove that. So I am going to remove this just to kind of show you what I'm talking about. So now you'll notice that we have this white space right here. And then, so all this white space, this is text. Notice that I don't have to use pound signs at the start of each line. It's just recognizing it as text. Now you may be asking about the pound signs up here. In this case, the pound signs are actually indicating that this is a heading. Within the R Markdown file, the pound signs are indicating a heading. So you'll have the pound signs, you can have 1, 2, 3, 4, and then space, and then the name of whatever heading that you're using. So the number of pound signs essentially is telling R Markdown. It's essentially an instruction for how large you want the heading. So, 1 pound sign is going to provide the largest heading. If you use 2 pound signs, it's going to be the next largest heading. 3 pound signs, it would be the next largest heading, and so forth. So at this point, this is just 2 pound signs, but I'll just I'll kind of show you some other stuff with that. I'll show you the different pound signs in a bit. But you'll notice that all this text right here, that's again, we don't have to use comment lines for that. You will notice too that it says when you click the knit button, a document will be generated that includes both content as well as output of any embedded R code chunks within the document. So that's kind of highlighting what I was talking about before. Code chunks contain your code for performing the analysis. So that's literally all what they're mainly used. You can also use code chunks for other reasons, like if you just want to create a code chunk for importing data or for using library function. Maybe I'm going to use functions later on that come from a set of packages, and I just want to kind of call up all those packages all at once. I could create a code chunk that incorporates that early on as well. The knit button that is being referred to, and by the way, these little asterisks right here, that is basically that's indicating bold. So that's like a little formatting thing to let you know of right there. Two asterisks on both, basically putting the 2 asterisks on both sides of, whatever's in between is going to be in bold. The notion of the knit button, you're going to see the knit button right up here. Okay, so with this knit button, what's going to happen is when you click this, um, it's going to knit together everything from your R Markdown file into an HTML file. Now, the R Markdown file is not going to contain the output itself. Okay, it's going to contain the text and it's going to contain the code. But when you knit, it's going to run the code and then stitch the text, code, and output all into the same document. So that's the really neat thing. And so your kind of your artifact, if you will, would be an HTML file in this case that contains all three of those elements. Okay, so you know, typically, I'm going to click on knit on save. I haven't really noticed that it really matters that much, but whatever. We'll click on knit on save, and so that basically the idea is every time you knit. What you're going to end up doing is you're going to overwrite the previous R Markdown file and any HTML file that has been generated previously with that same name is going to be overwritten as well. So you're not going to have like 1,000 files that are going to be working on. You're going to have your main R Markdown file and the HTML file, and then you can update as you go along as you're working. So that's just kind of a little FYI right there. So I'll scroll down a little bit further. You'll see that we now have another code chunk. So this code chunk, again, these are the three back ticks, if you will, and on a standard keyboard, uh, Microsoft keyboard, I guess, that would be kind of located next to the one on your keyboard, and I believe there's a tilde above it, at least on my keyboard. So keep in mind these are not quotation marks; these are backticks. That's it. So don't confuse the two. If you put quotation marks and you try to create a code chunk, you're not it's not going to show up. The code chunk shows up when you format it correctly. The code chunk is going to be in gray right here. So in the white space, you've got the text. The code chunk is going to be shown in gray. If I take out those three tick mark right here, you can see that now it's kind of extending the code chunk down further because there's also tick marks right here. And we don't really want to do that. I'm going to put those back in, and you'll see that right here, we've got more white space. We've got a header with two pound signs, and you can see that there's some text right there. This is just kind of, again, these are defaults that kind of come with our Markdown. And what we'll end up doing ultimately when we want to really, use real data or create a file with actual data and so forth that's not this cars data, then you can sort of eliminate all of this. But the original R Markdown file, when you open it up, it's going to contain all these defaults, and then you can just kind of cut out everything that you don't want to include, and then you can start writing your text and also incorporating those code chunks. But the next code chunk, right? So really quickly, the first code chunk, as I said before, it's got the three back ticks. Inside the brackets, you'll see it says R. And so right here, cars, this is your data frame that I was telling you about. Again, this comes with base R. And so essentially it's just kind of calling up that data frame. Most of the time though, you're working with data that does not come with base R, and so most of the time you're going to be doing something like this, where essentially you'll have R inside those curly brackets. You can also follow that up too by incorporating a couple of other options for eliminating warning messages or incorporating them, and also whether or not to evaluate the code chunk. When I say evaluate, that just basically means running the code, or if you don't evaluate the code, then essentially the code will show up in the output file, the knitted output file, but there won't be any actual output. It's just there you go. Um, so. Uh, if you Another option is echo, which you'll see kind of discussed below. But again, we're going to be using the cars data set. So I'm going to type back in cars right here. And so this first code chunk, we're just using a single function, summary function. And our argument is the name of our data frame, which is cars. Okay. So to show you what happens, I mean, one of the nice things is that I don't necessarily have to just fully knit the HTML file. I can determine whether or not things are working if I run the current code chunk. This little arrow right here, if I click it, then you can see it ran the code chunk. You'll also notice too that it generated down below. It generated, there's the function again, and then you can see the same output as above. And so you can kind of see your output on the fly. If you want to remove that, though, you can just click this little X to clear the output. Just kind of keep in mind, though, that that's the results of running the code chunk itself. But if you just, but if like I said, if you didn't evaluate the code chunk, then you wouldn't have any output that would show up, be rendered. But nevertheless, there you go. Uh, so now we got including plots. So that's essentially, this is just another little section here by default. And, there are two pound signs right there. So just for fun, I'm going to use one pound sign here. I'm going to go down and for including plots, 2 pound signs. And then down below, I'm going to use 3 pound signs. And then I'll just create something that says note right there. Now, what you'll need to do, though, is for the header, you're going to need, this is another code chunk, you're going to need to incorporate a little space right there for that to show up. So the third code chunk, you can see that essentially it looks like it's calling up another data frame. And you can see right here it says echo equals false. So basically this is an option that if you incorporate echo equals false, the default is echo equals true. So you don't actually have to have the echo option or argument right here. But if you don't want the code to show up in your output, you just want the output itself, then you can set echo equals false, and what you'll get is just the output when you knit your file. But again, by default, the setting is echo equals true. So you don't actually have to put that in there. And by default, then the code chunk will show up as well. Okay, so now that's just sort of a general breakdown of the RMarkdown file. So now let's knit this RMarkdown and save it. Okay, so right now, just kind of keep in mind that before we knit, we need to set a working directory. We want to know where on our computer we want to save our Markdown file. So to do that, we're going to set a working directory. And so essentially what's going to happen is then everything that we end up saving and everything, when we stitch the HTML file, there will be another file that's saved under that working directory. So what we'll do is we're going to click on session, and I'm going to go to set working directory and then choose directory. Okay, you can actually use a set working directory function, but then you've got to specify this path all the way from your drive, your C drive or whatever, all the way through whatever folders and so forth. It's a real hassle. I hate doing that. I invariably make mistakes when it comes to trying to, to type out a path through multiple folders and so forth. It's just ugly. So this I really like this because I don't have to worry about that. So I'm going to click on choose directory, and then I'm going to go to desktop and go to RMarkdown. Sorry, that's just the location where I'm going to save everything. So click on open right here, and so now you can see that the you can't really see it right here in the R Markdown, but down below in the console, you'll see that by doing that, it essentially creates that function, and then you can see the path all the way through that particular folder on my computer. So So, so that's it. And so I also find this extremely useful too, because like I said, I really hate trying to, let's say I want to incorporate automatically in my R Markdown file, setting the working directory, and then trying to import data from that a particular folder on my computer, uh, then it makes me not have to go through such a headache. Um, so there you go. So at any rate, we are now pointed R to a working directory, and that's where we're going to be saving um, our Markdown file and any other files that are generated. Also, in those cases where you are importing data into R for analysis, you also have to point your point R to that working directory. There are ways of using these ugly syntax to go from folder to folder. You could theoretically access data sets in other folders, but the simplest thing to do is just point the direct set the working directory where the data is, and then when you do that, you can access the data set, and then when you run your analyses, everything that's saved and everything will just be in that particular folder. So there you go. All right, so at this point, I'm going to use the knit function right here. And right now, by the way, you can see up above the tab, it says Untitled 2 right there. Untitled 1 was our script. We just never titled that. By default, we have Untitled 2. So when I click knit right here, it's going to force me to name the R Markdown file. So I'll name the R Markdown file. I'll just call it example R Markdown. And you can see that the file type is RMD. So it says save as type, capital RMD. So that's the R Markdown file type. So now when I click on save, by automatically it is knitting. So there you go. You can see a little stop sign down below. It kind of goes off. And now that here is our HTML file. So you can see that we have, there's the name of our file. This is all the metadata right here in this little area right here. You can see that there's our header for our markdown. That was the 1 pound. You can see the text underneath. That's in the white space. You can see in the gray spaces, these are the code, that's the code within those chunks. So the first function that we have right here is a summary function. And so it's a summary function applied to cars. And so you're getting some general descriptive information right there. I rarely use the summary function for this kind of purpose. Most of the time, I end up, most of the time you're using the summary function when you fit a model and then save the results of fitting that model to an object, and then you use the summary function to call up the object that contains the results and so forth. So, but here, this is just like a little thing containing our two variables. You'll notice as we scroll down below, there's the next header. You can see that the second header is a little bit smaller than the first header. That's because we use 2 pound signs. There's a little bit of text right here. Remember that because we had the option echo set to false, there's no code that shows up for this. All we're getting is the output. In this case, it's just a plot. And then down below, you can see there's another header. I just created that name set for note, and that's where we used I think 3 pound signs, and then follow that there's like a little bit more text, and that's actually describing that echo parameter. So at any rate, at this point, we've now knitted together text, code, and output all into the same HTML document. So you can also open this in a browser. After you knit, you can click on Open in Browser, and there you go. It's opened up. In this case, it's opened up in Firefox. That was my default browser. But let's say, for instance, that I don't want to have to go the process of re-knitting just so I can get an HTML file. Well, guess what? In that folder, we have the saved R Markdown file. We also have an HTML file. And so, like I said, I have my default set for Firefox. But if you use, like, if your browser was set for Google or something like that, then you can open up using Google. It might prompt you to say which browser or something do you want to use. Could happen. It didn't happen here, but and so you could theoretically um, uh, you know give that information and it would work fine. So at any rate, if I double click on this, you can see it reopens up in the browser. So what that basically means then is that you can take, again, the text, code, and output from your data analysis and create this file that then you can save for future reference as documentation, and you can also send that HTML file to maybe co-authors, or people who are interested in looking at the code that you have presented. You'll notice that that a lot of like if you go to various tutorials on the web, you'll notice that a lot of tutorials with R are written using R Markdown files. And essentially, kind of is doing this kind of number right here. Um, haven't quite mastered the art of getting it there to stay or anything like that. But there are obviously ways in which you can essentially create a web page that is available, and you don't have to kind of recreate this over and over again if you didn't want to. But for my purposes, I am not interested in that. I've not done that, and so this is pretty much where I tend to land in terms of kind of the artifact that I want to generate. So like I said, this is an HTML file, and you can also create PDFs. But again, to do that, you would need to incorporate, you would have to install, packages that like latex package or packages that essentially address that type of formatting and so forth. So at this point, there you go. We now have our example of an R Markdown file. So now what I want to do is show you another example where we're going to import some data. And this kind of gives you a better idea of some of my workflow. And excuse me, you may find this useful in your own work. So this data set right here, psych underscore reg underscore DAT, that is a CSV file. So what we're going to do is import the CSV file. And what I want to do is set up my R Markdown file so that um, when I use that R Markdown file, I can, I can access the R Markdown, the data set automatically, essentially automatically import the data and for future use. Okay, so I'm going to just kind of give you an idea of some of my workflow, and which you may find useful for yourself. And in fact, this is I would say this is pretty good practice. But at any rate, I won't toot my own horn that much. So at any rate, what we're going to do is we're going to create a new R Markdown file. So what I'll do is I'm going to click on File, go to New File, and then go down to R Markdown. And so I'm going to call this, I'll say example with regression data. So let's just say that, I was going to do some descriptives, maybe run a simple linear regression or something like that. That's just going to be my title for right now. So it's still set up for HTML. I'm going to click on OK. And so again, I do want to mention that when you are the original file has all of these defaults, so you can remove those and there's no problem. Just keeping in mind that you have white space is for text, code chunks is for code. And I will say too that you can use the commenting within the code chunks. Oftentimes I'll add a little bit of comments here and there, but you cannot incorporate uncommented text within a code chunk. Otherwise, you're going to have the same problem that we saw using the console and using the script editor. Okay, so at this point, what I'm going to do is I'm going to get rid of all this stuff right here. So I'm going to clean that out, and I will be creating an initial code chunk. I'm going to do my 3 backticks, curly bracket. I'm going to type R right here, and then enter, 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 and I'll just do 3 backticks right there. Most of the time when I'm creating code chunks, I set it up this way, and then I can just enter the code in there or whatever comments and so forth. And you can keep adding, adding or taking away or whatever. But I find that, going ahead and creating the code chunk, this is a friendly reminder that if you don't add the code chunk, if I let that out inadvertently, and let's just say started text down below or creating text or whatever, that's going to be an error. So you got to basically create those, incorporate those 3 backticks to start, 3 backticks to end. Okay, so what I'm going to show you here is just kind of a quick way of getting data imported and then having the RMarkdown set up so that every time you run it, it's going to import the data, and then if you're making modifications to the code along the way and so forth, you don't have to keep re-importing the data every time you close out an RMarkdown file. It'll just have the code to import automatically, and then you can just make whatever revisions and so forth, and it just makes life a lot easier. At least that's my opinion. So the first thing I'll draw your attention to is, again, we want to set our working directory. And I believe, in this case right here, it's just good to go ahead and choose a directory. It's already set for our markdown instruction, but if you were using a different folder or whatever, you would need to reference the folder that contains the data. In this case, our data is in this particular folder on my desktop. So I'm going to click open. Okay, and you just keep in mind, you're not going to actually see any files. This is just about, directing R to that folder, period. That's it. So I'm going to click open. And so now, looking at the code chunk below, you can see, and basically this was from our previous, this is from our current, obviously it's the same, but there's set working directory function. And then you can see inside the quotation marks, there's the path all the way through the folder. So the folder that we're setting our working directory to is RMarkdown_instruction. Now, when I'm running my analyses, I'm going to probably want to go ahead and do this. So what I'll do is I'm going to copy this and I'm going to paste this in right here. So at this point, if I run this code chunk, it's going to set the working directory such that is pointing to this folder right here. And certainly, if there were other folders on my desktop that I wanted to point to, I could change this as well. But like I said, I'm not a big fan of having to write out the path all the way to a folder, particularly if there's like a lot of embedded folders. That's just really a serious headache. And so doing this is pretty efficient, I would say. So now we in this code chunk alone, we are essentially pointing to that particular folder. If I click the little green button right here, that's just highlighting that, okay, we've set our working directory again. That's it. There's your output. And you can find that down in the console. You're not going to see anything up here, but you will see it down below in the console. Now, the next thing that I'm going to do is I'm going to import the data of that particular CSV file into R and or RStudio. And I'm going to use the import wizard. Like I said, you can go through the process of typing in, using the library function to type in the package to read in the CSV file, and then also, the path to the data, and then saving it to an object that's going to basically an object that's going to be a data frame that can be used for further for your analyses. Um, that's a lot of work. And so I'm going to use File. I'm going to go to File, go to Import Data, and I'm going to use the Import Wizard. And the reason, the benefit here is not just to import the data for for the purpose of this particular analysis, but I want to also get the code that I can take and put it into that code chunk above, and then have it, and then so that whenever I run the analysis, run the RMarkdown file, anytime I knit, it's going to call up. It's going to do the import, save it to a data frame, and then all subsequent analyses referencing that data frame will be carried out. So there's a couple of options. You got base right here. That's, you can import through that. That's just or text files through that. I'm going to use from text using the reader package right here. You also notice that there are other imports. You can also use other import other data types. There's Excel, SPSS, SAS data, and so forth. But again, I have the data saved as an SAV file. So I'm going to click on From Text. And so now you'll see it says Browse. So so before I do that, I'm going to draw your attention over here where it says Code Preview. So I'll just kind of draw a little arrow there, Code Preview. So under Code Preview, this is where things stand right now, even before you actually import the data. So you can see it says Library, and it's calling up the reader package. So you're using the library function to call that package up. You'll notice that it's got dataset. So that's just a generic name for, in this case, because there's no dataset that has actually been selected yet. That's the default name, and you can see it says read read underscore CSV. That's the function to actually read in the data. That is a function in the reader package right here. And then you also see there's a little view data set. So at this point, we haven't done anything yet. We haven't imported the data. I will draw your attention also over here where it says name. It says data set. That's what I'm talking about. So that's the name of the data frame that will be where the data is saved, if you will. So at any rate, we're going to click on Browse. And there's actually a couple of CSV files right here. They're actually the same. I just kind of shortened the name right here. This is just a simulated data set. And I'm going to click on Open. And so when I do, you'll see that there is kind of a preview of, that contains variables and also your data. So there you go. And so now this is actually the name that is being given right here is actually the name of the the stem part of the name of the CSV file. So it doesn't have .csv because we're saving the data from the CSV file into a data frame, and that data frame is named psych underscore reg underscore data. And that's the default right there. I will mention too that, oh, and by the way, another thing to keep in mind too is you'll notice there's some of these tick marks right here. If your data has row names, you'll definitely want this to be clicked right here. This is the default. It may be the case that sometimes people might want to not have row names. I don't really know really why not. Very, very rarely would I want to do that. But if you didn't, then I guess if the CSV file didn't have row names, then I guess you would uncheck that. But at any rate, another thing I want to point out is that sometimes when you are importing a data set that has a lot of that's really just the name of the CSV file or SAV file or whatever is really, really long. That can be cumbersome after it's been saved to a fit object or an object that contains the data, because that's going to have the same long name as the original file name. And so that makes a lot of processes difficult or it can be kind of a challenge to use certain functions where you're trying to subset from a data set. Doesn't mean you can't. It just makes it kind of a headache. It's a lot easier to make mistakes when you're trying to do certain things. And so, I generally prefer to use shorter names. So you'll notice, oftentimes on the web, if you're looking at an R tutorial, you might see something like where the name of the data frame is something like data or my data, things like that. Those are names that they've given. It's nothing special. It's just literally the name. So I could, over here under import options, the name right here, I could change this. I could change this to data right here. And then what that would mean is that when I import, the data would be saved into a data frame named data, or I could save it as my data. Same thing. I could call this reg data, like if I wanted to refer to regression data, you can do that. It doesn't matter. Basically, it's going to save the CSV data in our case right here into a data frame where we've actually changed the name so that it's shorter and easier to use. I'll go ahead and for this case, I'm just going to call this my data, and we'll click on import. Okay, so now the data has been imported. You can see that we get, right here, it says my data. And you'll notice over here in the global environment, it says data and it's got my data. That is going to be how between this little tab opening up and the global environment incorporating the name of our the data frame and a little bit of a description there. That is going to tell you that yes, we have imported the data set. So now we can use our functions and so forth in order to carry out our analyses or whatever analyses that we want to carry out. Okay, so with that in mind, we're going to go back to our Markdown file that we're starting to create right here. We haven't named it yet, by the way. We certainly could name it. We could either we could go to File, Save As, and we can name the R Markdown file that way. It's still pointed in this case to that particular file on my desktop. No biggie. Or you can, we could just save it when we knit. Either is going to be fine. So so the thing to keep in mind is, like I said, I want to import the data. I want to use this particular folder to save my Markdown files, HTML files, and also to access the data and just kind of have it all in one spot. So what I'll do in this particular case is you'll notice that down here there's the my data. So this is the code that was generated when we read the data in. Now keep in mind that we don't want to just simply use this. We also have to make sure that also in the code there's a library function and it's essentially calling up the reader package or read R package, whatever. If we're going to use the read CSV function down here, we have to call up that package. So obviously I could type that in the code chunk above. I am lazy and I'm just going to copy this up here and don't copy the cursor, the little greater than sign cursor thing, because if you do, it's not going to work. But we could copy that as well. Again, I didn't include the little cursor thingy, and we'll excuse me, paste that in. So now if I click on this little button right here, run current code chunk, you'll notice that there's no error messages. There's a little bit of information right there, but it's not really all that interesting. If I want to not see that anymore, I can do that. But basically that, the information is repeated below. When I ran that, though, when I ran this code chunk, you'll see the code reappear in the console down below. But we didn't generate anything. This is just to import the data, period. That's it. Okay, so now what I can do, just to kind of show you what I'm talking about on some of this stuff, let's go ahead and knit. Let's just go ahead and knit an HTML file with just what we have right here. So I'm going to click on knit right here, and you can see our markdown instruction. I'm going to call this um, R markdown and example. I'll call this reg data. Okay, so because the other markdown is from our earlier example. So I'll save right here. And so now when I save it, it's knitting. And so you can see a little stop sign down below. When that goes off and when the HTML file appears, you got it. So you can see down below, there's a little bit of information right here related to the import itself. That might not be necessarily something that I find interesting. Let me see if I can get rid of that from the output file. I'm going to use message equals, and I'm going to set this equal to false. So if there's any messages, then hope in theory, if that is considered a message, then that should be eliminated. But this is just basically an option. The default is true. So any messages that are produced, it's going to show up. But if you add message equals false, then now you're resetting so that no messages appear. But again, this is going to depend on whether that is considered a message. So I'm going to click on knit again. Ah, beautiful. Okay, so it's gone. So all that other junk that we saw no longer there, and so it now looks a little bit more pristine, if you will. So at this point, we haven't run any analyses. We just imported the data, and we've created a code chunk where we are setting the working directory and then reading in the data, so that in the future, after I create this today, if I want to run analyses or modify the R Markdown file, modify text or code or whatever, and I want to generate a new HTML file, knit it together and so forth, it will automatically import that data. I will say too that right here, you'll see that obviously with the set working directory, when we pointed it, we got that path all the way through our folder. You'll notice down here, there's no path. There's no path that's given. Um, if in this particular case, the reason why is because we have set our working directory in reference to the data set. There you go. If you wanted to import from a different file, you would have to have a different path. And honestly, it just gets kind of ugly, and then so forth. So that's just my 2 cents on that. So at this point, I'm going to click out of that, and let's now incorporate some code. And so I got my little cheat sheet right here. Uh, Wrong one. Nope, that's it. Okay, so let's say that I want to first look at the structure of the data. In my data frame named my data. So I'm going to create another code chunk, and we'll type R right here. There really is not going to be any messages or anything like that I have to worry about. So I'm going to just leave that alone. So I'm going to create my little code chunk here. And I'm going to say, and in the text, by the way, this we can incorporate information about what's going on. So literally you can document what you have done throughout the document. It's going to be stitched or knitted into the HTML. So we'll just say, the code chunk below um, sets the working directory and imports the raw data from the folder on my computer, whatever. There you go. Okay, so there you go. So that tells me what's going on right there. And you can add any commentary. A lot of times when I'm creating, a lot of the stuff that I create for my classes where I'm using R Markdown files. I can incorporate a lot of instructional materials and so forth, and I can use code chunks to provide examples and so forth. So that's really a good component of being able to use our markdown files. So that ability to create text and to knit it into a document such as HTML. So that's the first right there. Let's say I want to examine the structure of my data or of my data. And now in this code chunk, I'm going to use the str function and we'll type my data right there. So, obviously I can check this. I don't have to knit it necessarily. I can just run the current code chunk. Now that I've imported up here. Now, the thing is that uh, to this point, if let's say that I've created all this code above, or let's say I haven't imported the data. Let's say there was an error up here in the importation or setting working directory where the data wasn't imported. Then if I run this code chunk down here, I'm going to get an error message because my data is not going to be recognized. It's not going to be in the environment. It's not going to show up over here in the global environment. So so just kind of keep in mind that when we set our working directory and import the data, we want to make sure there's no errors and so forth so that it's cleanly imported. And then in subsequent code chunks, we can, when we knit, everything will work fine, or at least everything until there is an error in coding later on or something. But also, because we've already knitted, then basically now it's going to recognize that that we're using my data as the argument to the structure function. So I can look at the current code chunk, run the current code chunk, and you can see there it is right there. So there's all the information. So you got, within this, depressive symptoms, life satisfaction. Those are the names of the variables. You can see num or num. That is basically indicating a numeric variables, and all the data, all the variables in our data frame are right now recognized as numeric. I'm going to get rid of that right now, but let's go ahead and restitch just to kind of take a look, or re-knit. Yes, I don't know why I keep going back and forth with stitch and knit, but same thing, right? Okay, so now when we scroll down, you can see there's my little comment right there. There's my comment above right here. Again, you don't have to use pound. You don't have to comment them out because it's going to wrap around and it's going to be okay. So you can see right here we have our code chunk above. We have our code chunk right here. And then we have our output. So down here, you can see that this is essentially our, all of the attributes and so forth of our the variables in our data frame. This is, again, talking about the structure of our data. And so there you go. That was pretty easy, right? So I will mention too, another thing, since we're already kind of here, is that, and it's very useful to know. Right now, when I use the structure command, or if I use other functions such as describe from the psych package, if I just reference the data frame, it's going to give me descriptives for every variable, or in this case, it'll give me the structure information related to all the variables in the data frame. And so it might be the case where I might want to subset out maybe one or two variables and then get that information on those variables and not have everything in there. So, this is particularly going to be useful in those cases where you have really a lot of variables in your data frame and you don't want to, have to have, 15, 20 pages of attribute information in your HTML file or whatever, because it's going to give you all, literally everything, right? So you can subset out, where you're describing, um, uh, you know, variables that are going to be involved in your particular analysis. And so there's a couple ways that you can do this. I'll quickly also structure of the data and describe data. So I'm going to add in, after structure right here, I'm going to type in library and then psych. So remember that to use the psych functions in the psych package, such as the describe function, you have to use a library function to call that package. So now what I'll do is I'm going to type in describe, and then we'll use my data right here. So what's going to happen is it's going to give me descriptive information on all the variables. So when I just visually run the code chunk, that gives you a kind of an idea right there. You can kind of click on these to get, a little bit more detail. There's a little button right here, arrow that you can kind of sift through. Um, so again, that's useful to because if there's an error in this code chunk, then it's not going to run. So that's kind of a nice thing. Let's say, for instance, I forget to include my closing parenthesis. You can see over here there's an X that just says, "Hey, there's an error here." And it's basically giving you an idea about what the problem is, which is I don't have the closing arrow. But I will show you if I try to run this, you can see down below incomplete expression, and you can see it showing up in red. So this is a very simple example. There will be times where, in more complex cases, it's not so easy to identify where the problem is, and sometimes the error messages that you get can be rather cryptic, and so you have to sort of sort through and try to figure that out. And a good way of helping you might be to use ChatGPT or an AI to maybe you put the code chunk into that and then say debug, or hey, what's wrong with the code, this code right here. You could do something like that. There you go. Let's see here. Okay, so at this point, um, in fact, I'll just do that really quickly. I'm going to open up ChatGPT, and it's just basically going to give me what we already know, which is that there's not an in parenthesis there. But let's say I just, imagine this is a more complex situation, and I copy this code, and then down in ChatGPT, let's say I say, please debug. All right. And then I'll, if I press shift and enter a couple lines, I mean, you could theoretically just paste it in. It's going to work fine, but I like a little bit cleaner look. So there you go. So there's the code. And then I press a little arrow, the up arrow, and then it's going to kind of go through. And so it's giving a straight diagnosis, uh, you know, uh, basically it's print only function. I don't know what's telling you right there. But in a nutshell, let's see, huh, right. So it's giving me a lot more information that maybe I don't need in this particular case. A lot of times you should be able to, yeah. Well, believe it or not, sometimes you have to be a little bit more explicit about what's wrong. So, so in this particular case, let's say, assume the data has been imported in R of into and saved to data frame named my data. Okay. What is wrong with the following code chunk? What may have just happened is that it didn't know that I had already imported, the data itself. And so maybe that's probably the problem. So I'll say the following code chunk. All right. It doesn't work. Failure semantic. Okay, let's see. Okay. All right. Again, it's giving me way more stuff, and it's not really identifying the actual problem in this particular case. I do want to mention too that with AI, um, sometimes this is the stuff. What you get is heavily dependent on how you frame the prompt. The clarity. I don't know that I was as clear as I needed to be. Another thing too is that I could theoretically save the R Markdown file, import it, and then have it evaluate the R Markdown. I could do that as well. But as I'm kind of working through, you can go section by section and just kind of, in theory, and more often than not, it can be quite helpful. But in this particular case, I guess maybe it's just not picking up for whatever reason that very, very subtle uh, issue. But anyway, I'll kind of go back here and I'll just add that back in. And, we already know what the problem is. So just kind of keep in mind, if you're using AI, it's heavily, what you get is heavily dependent on the precision of the prompt itself. If you're too global or whatever, it's going to figure something out. It's going to give you something regardless. And so it may not necessarily give you this, address the specific question that you want. And then also keep in mind that generative AI like ChatGPT or Gemini and Claude and so forth, those are essentially stochastic and they reflect stochastic processes. And what I mean by that is they're non-deterministic. So if you run, if you use it, you could use the same prompt twice, like in ChatGPT, and the formatting may be different. You might get a longer answer, shorter answer. Um, Sometimes it's possible too that that you might get different information. In which case, you would want to cross check, of course. But the point I'm making is that when I say it's non-deterministic, that means that you're not going to get necessarily the same format and or answer all the time. And, most of the time, if there's a good training data that has been used to train like ChatGPT or whatever, if there's good data out there, like on the web, and it pulls that data, then more often than not, you're going to have you'll have greater consistency if there's, if it's kind of repeated out there, and then the accuracy of the information will be greater. But if you have poor training data like that, maybe there's like a very niche issue that needs to be that's been addressed, maybe you know, on Stack Exchange or something like that, and there's just not really a lot of conversation on that, and there's not really a lot of traction, and the information is dubious at best. Then the information you get from like ChatGPT will be much more questionable. So a lot of times what I do, by the way, is I try to have ChatGPT. I give it specific prompts to critically evaluate its own claims. I also have it evaluate my own claims. I find that's really useful as well. But that is a long digression from the main point of all this, and that all started with that. Not including the little end parenthesis right there. So sorry about that. So we'll go ahead and, as I said before, let's say we want to subset out um, one variable, for instance. Let's go down. I'm going to create another code chunk. By the way, as you can see, you can incorporate multiple functions, and processes within a single code chunk. You don't have to go blow by blow like you would with the console. But but you also want to be careful not to make the code chunks so extensive that if there is an issue with the coding, like if you try to run the analysis and or the NIT, and the NIT didn't work, and there's an error message, and you don't, maybe it's something that's very cryptic, then in that particular case, it can be very hard to diagnose when you have a lot of code in a code chunk. So, in that particular case, you might create, additional code chunks with pieces of it, and you can check each of those out individually, of course. But in this particular case, a lot of times, if I'm running data analyses, and I can incorporate multiple functions within a given code chunk. But if there is an error message, a lot of times my strategy is then to go by blow by essentially creating additional code chunks with portions of that more massive code that I had used. So at any rate, in this particular, so what we're going to do right here though is we're going to look at subsetting out variable or two. So keep in mind that what we'll do is, let's say I want to use the structure function. So I'll type in str, and I just want the structure associated with one variable. So in this particular case, I'll type in my data, and we'll use the dollar sign. The dollar sign basically is going to be, it separates the name of the data frame and whatever variable that you want to select out. So in this particular case, let's say I select depressive underscore symptoms. So in this particular case right here, I'm asking for the structure in reference to that particular variable. And if I hit the little green arrow right there, you'll see that I get that information. You can see it's a numeric variable right there. It doesn't give the name like you would see, above. If I run this again, it doesn't give the exact names like you saw there. Like if I go down to the yeah, there's the structure information for all of our, for our variables there. Um, it's just going to basically give you that. But you do know that what's been called up is information related to the structure of that particular variable. So think about this, that the dollar sign is essentially allowing you to subset out certain information. In this case, we're subsetting out a variable. Uh, well, the dollar sign is to subset out a variable, and then we are applying the function, the str function, to that subsetted variable instead of the entire data frame with all of the variables included. So that's an important thing to keep in mind. It's really handy. It comes in handy a lot, and so that's something to definitely keep in mind. Now, let's say, excuse me. Let's say I want the structure of two variables. Let's say I type in structure and I want to type in my data. Now, in this case, the dollar sign is not going to work. So what I have to do is to essentially create a list uh, that references the variables that are in the data frame to then to serve as arguments to the structure function. So the way that I do this, I can't use a dollar sign. I need to create that list. So I'm going to first create a bracket right here, and then I'm going to use C, and inside that parentheses. So you'll notice that the C parentheses, that is a function. It's a list function. And so essentially what we'll do is we'll type in the names of our variables in quotation marks and separated by a comma. So if I have three variables, all three of them have to be in quotation marks and all three have to be separated by commas. But that creates a list um, that is essentially of variables that are going to be subsetted from the my data frame, and then that subset is going to be applied. We're applying the structure function to that. So at this point, we don't have anything. So let's go ahead and create our list. So let's say that we're going to use depressive underscore symptoms. Like I said, you can see right here we have a long variable name, symptoms, and so it would be easy to leave out the underscore or inadvertently put a period or something like that. If the name does not exactly match the name that is in the data frame, it's not going to work and you'll just get an error message. So, but we do know this. I'll do a comma and then I'm going to type in stress right here. I do know that that's another variable in the data frame. So now when I press the arrow, you'll see that now we do get the variable names, and then also you can see that both of them are identified as numeric. So instead of getting all the information from all the variables, now we're just getting information with respect to those two variables. So long story short, when it comes to subsetting, you can use the uh, dollar sign to subset out one variable and then apply the function to that variable. You can use the C list function to create a list of variables if it's more than one, and then subset that out and then apply the structure function to that in this particular case. We can do the same thing with respect to the describe function. So let's just kind of go down. I'm going to use, let's see, Yeah, I don't have anything further. So we're going to use describe from the psych package. So I'm going to type R right here, create all of that. I'm going to type in library and we'll type in psych right there. Okay. And basically oh, let's see. Yeah, I guess we already did that. Well, we already used it. So up here, if I was to knit, because we've already created the library function and knitted, and also kind of run these things in order, then there's really that's not necessary to use the psych function here. But, if I was to create code, like in a code chunk, where I use a function for that comes with a package that has not been called up by the library using the library function, then I'll get an error message. But I don't really have to worry about that in this particular case because we've already called it up. So I can still use the describe function as is. So I'm going to type in describe, we'll do describe uh, depressive symptoms. So I'll type in my data, $ depressive, and I'll just fill that in right there. That's nice. And so we'll highlight that and click the arrow. And so now you can see, again, it's just giving a non-descriptive X1, but we do know that is for depressive symptoms. If we want to describe for that list for depressive symptoms and stress, we can do that as well. So I'll use describe and my data. And then essentially the brackets are used for subsetting. I'll type a C, and then we'll type in depressive underscore symptoms, and in quotation marks, and then stress inside quotation marks. So keep in mind that we have a C function that is nested within the describe function. Okay. So it's very easy. As you can see, right, we have to close everything out. We have to close all our parentheses out. We have to close all of our brackets out. So the innermost function is actually the C function right here. And so you've got the beginning and ending parentheses. So you got essentially that function is going to be closed out. The arguments to that function are depressive symptoms and stress. And that's where we're creating a list. Then the brackets right here is not so much a function, but it's essentially used to subset. So, and we're subsetting from the my data frame. Okay, so in this particular case, so with that subset, that subset of variables is then going to be the describe function is going to be applied to that subset. So right here, just kind of running that, you can see now you got like two boxes. These are just little previews. And you're going to get the same thing when you knit, by the way. And this is just kind of like as you're working through, you can check if that's not good enough or if it's just too ugly down there in terms of what the output looks like or difficult to kind of read through. You can knit and it's going to work exactly the same. But so right here, this is the first data. This is descriptives for those two variables. This is the other one where we just subsetted out the depressive symptoms variable. Okay, so now we've got those. We'll take a quick peek at the knitted HTML. So I'm going to rerun this. Okay, so now you can see that as we scroll down, there's our psych package. That's the original describe right there. Going down, there's our structure function for depressive symptoms, structure function applied to depressive symptoms and stress. And then there's our code chunk, describe my data, depressive symptoms, basically. So we subset out depressive symptoms variable. And then, so that information is given in that following little space right here. And then you can see the describe function applied to the subset of my data in the form of the variables descriptive, depressive symptoms and stress. And so now you've got, the mean, standard deviations, ends, and so forth for those two variables. There's also skew and kurtosis there, by the way. Okay, so at this point, when I've run all this, just to show you, when I ran all this and knitted, there's our original RMarkdown. And so now this right here is the HTML file. And so I can call this up very easily. I can just essentially double click and it's going to uh, open up my in your browser. And so my browser is Firefox right here. If you're using Google or something like that, obviously you can call it up for those for any of those browsers. But that's so it's opened up in my browser. But again, the nice thing about all this is that the R Markdown file right here, as you can see, it's just basically text and instructions for knitting an HTML file. That's it. And so when you run when you do the knitting, then you get your final product, which is the HTML file that contains your text, your code, and your output. Period. That's it. So I'll give you one other example. And so, yeah, and with that output file, you can share that with colleagues, or you can share it on the web or whatever. It's going to work fine. Um, a lot of times if I'm creating an R Markdown file, uh, you know, um, oftentimes I'll probably just share that as well. But the final knitted product is easy, easier to read and so forth. But yeah, there you go. So at this point, let's do one other thing. I'm going to run just a quick simple linear regression, and you can see things a little bit further. So I'm going to create another code chunk. I'm going to be essentially using the LM function. So we'll type in fit right here and then LM, and you can see this is a function because there are parentheses right here. And what's going to happen is that I'm going to fit a regression model to the data, and I'm going to save the results of that fitted model to an object that's named fit. Okay, this object can be anything. Just keep in mind that this right here, the less than sign followed by a hyphen, that is an assignment operator. So essentially what we're doing is we are assigning the results on that occur on the right hand side to an object on the left hand side. That's it. So at this point, what we'll do is we'll kind of write up our we'll write up our let's see, we'll write up our code. So what we'll do is we're going to just regress depressive symptoms onto stress. So I'm going to type in, uh, so the first argument to this function is essentially the formula or your model. So I'm going to type in depressive underscore symptoms, then a tilde. So that's our indicator that we're doing the regression. And I'm going to type in stress. Now, if I try to run this right now, you'll see that I'm going to get an error message, and it says depressive symptoms not found. And the reason why that's the case is we haven't referenced specifically the data frame. The data frame, so we incorporate the data argument so we can find where the data is. So when we type in data equals, we're referencing the data frame, which is my data. All right. So with the inclusion of that argument right there, when I run it, you'll see that now it's been run. There's no output, but there's definitely no error message as well. And the reason why there's no output is because all we've done is we've saved the results of our regression to an object that we've named arbitrarily fit. Um, so the next thing is we're going to use the summary function and apply that to the fit object. All right. So at this point, if I run, now you're going to see, first off up here, we've got the output. That's the regression. There's our regression slope, standard error, t-value, and so forth. All the regression output right there. Also down below, you'll see it in the console as well. So at this point, if I knit, you're going to see all of that appear in the HTML file. Okay, so now we have our HTML file, and so there it is. Example with the regression data. Actually, I haven't incorporated any headers in here. I could, and I haven't incorporated any additional text as well. But as you can see, we can certainly incorporate that. So as we go through, you can see that this is our final linear regression right there. So this is the code chunk with that. And then down below, we've got our regression output. So as you can see, we've got our text. We've got our code right here. We've got our code right here. And then we've got our output right here. And so that, my friends, is the big benefit relative to just using the script editor. You can't put all this into a single file that's easily digestible or just in a single file because the output's not going to appear. You will have the code, but you won't have the output. And so that's really the big payoff of the R Markdown file. And that's what makes it easy. You can use it when you're, like I said, for documentation during your data analyses, what you did. You can write in interpretations if you want. You can, annotate the code if you want. Just keeping in mind that if you are annotating within a code chunk, you'll need to you'll need to comment uh, those uh, those annotations in within the code chunk. But outside the code chunk, um, you don't have to actually you don't have to, and you shouldn't use the pound signs. I mean, try to comment in using the pound signs. The only, the pound signs that I was referring to in the text, like I said, we were kind of going through it earlier in terms of the headings that you would include. There's now one other thing that I do want to point out is that that for each file type that you want to knit, like if you want to knit HTML or you want to knit PDF. Um, there are certain formatting rules, and so some things will generalize okay, but sometimes if you set up code, like if I'm using HTML code itself when I'm setting up the R Markdown file, then when I knit, let's say I knit to a PDF, the text should largely appear. But if there's formatting things in the text, or like formatting of tables and things like that, you can also incorporate tables as well, and also equations and things like that in our Markdown file, and then knit that as well. But those formatting things may not necessarily generalize to a different file type. Long story short, you have to sort of uh, you'll kind of have to reference those formatting rules. If it doesn't really matter, I mean, for a lot of practical purposes, if you're just kind of doing standard annotations, you're including interpretations and so forth, then probably outside of headers and maybe a few bolds and things like that, you're not really going to be that interested in creating tables in R Markdown um, or incorporating equations and things like that. But if you are like in my case, when I'm creating a lot of instructional materials with tables and equations and things like that, in those cases, that then the formatting for one type of file type like HTML may not necessarily generalize very well to PDF. And so sometimes what I do in those particular cases is I might submit my R Markdown file to like ChatGPT and say, kind of evaluate this, or I might say, actually, instead of that, I might say, um, you know, construct an R Markdown that takes this format in HTML and render it so that it as closely as possible approximates our PDF, or the opposite. You can do it that way. But at any rate, those are just a few things to kind of keep in mind when you're creating R Markdown files. You'll find on the web there are various tutorials and cheat sheets if you want to get into more deeper things like I said, creating equations or adding Greek letters. Inline or separate or whatever. Um, uh, Let me see what else. tables as well. They're formatting aspects of tables. So you'll just, this is obviously a very long introduction, so I'm not going to go into those things, but I'm just letting you know that that stuff is available on the web. So that's going to wrap up this discussion on using, you know, uh, why use RMarkdown, what's the benefits over using the console or script editor in RStudio. Hopefully by now you see the benefit. And obviously I've walked you through the steps of actually creating our Markdown files. And so hopefully you find this helpful, and I appreciate you watching.